Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 2, Projection Section Perspectivity, Elementary Configurations. Section 13, Projection Section Perspectivity. The point, line, and plane are the simple elements of space. We have seen in the preceding chapter that the relation expressed by the word on is a reciprocal relation that may exist between any two of these simple elements. In the sequel, we shall have little occasion to return to the notion of a line as being a class of points, or to the definition of a plane, but shall regard these elements simply as entities for which the relation on has been defined. The theorems of the preceding chapter are to be regarded as expressing the fundamental properties of this relation. We proceed now to the study of certain sets of these elements and begin with a series of definitions. Definition: a figure is any set of points, lines, and planes in space. A plane figure is any set of points and lines on the same plane. A point figure is any set of planes and lines on the same point. It should be observed that the notion of a point figure is the space dual of the notion of a plane figure. In the future, we shall frequently place dual definitions and theorems side by side. By virtue of the principle of duality, it will be necessary to give the proof of only one of the two dual theorems. On the left, definition: given a figure F and a point P, every point of F distinct from P determines with P a line, and every line of F not on P determines with P a plane. The set of these lines and planes through P is called the projection of F from P. The individual lines and planes of the projection are also called the projectors of the respective points and lines of F. On the right, definition: given a figure F and a plane pi, every plane of F distinct from pi determines with pi a line, and every line of F not on pi determines with pi a point. The set of these lines and points on pi is called the section of F by pi. The individual lines and points of the section are also called the traces of the respective planes and lines of F. If F is a plane figure and the point P is the plane of the figure, the definition of the projection of F from P has the following plane dual. Definition: given a plane figure F and a line L in the plane of F, the set of points in which the lines of F, distinct from L, meet L is called the section of F by L. The line L is called a transversal, and the points are called the traces of the respective lines of F. As example of these definitions, we mention the following: the projection of three mutually intersecting nonconcurrent lines from a point P not in the plane of the lines consists of three planes through P. The line of intersection of these planes are part of the projection only if the point of intersection of the lines are thought of as part of the projected figure. The section of a set of planes all on the same line by a plane not on this line consists of a set of concurrent lines, the traces of the planes. The section of this set of concurrent lines in a plane by a line in a plane not on their common point consists of a set of points on the transversal, the points being the traces of the respective lines. Definition: two figures F1 and F2 are said to be in one-to-one correspondence, or to correspond in a one-to-one reciprocal way, if every element of F1 corresponds to a unique element of F2 in such a way that every element of F2 is the correspondent of a unique element of F1. A figure is in one-to-one correspondence with itself if every element of the figure corresponds to a unique element of the same figure in such a way that every element of the figure is corresponding to a unique element. Two elements that are associated in this way are said to be corresponding or homologous elements. A correspondence of fundamental importance is described in the following definitions. On the left, definition: if any two homologous elements of two corresponding figures have the same projector from a fixed point O, such that all the projectors are distinct, the figures are said to be perspective from O. The point O is called the center of perspectivity. On the right, definition: if any two homologous elements of two corresponding figures have the same trace in a fixed plane omega, but all the traces of either figure are distinct, the figures are said to be perspective from omega. The plane omega is called the plane of perspectivity. Definition: if any two homologous lines in two corresponding figures in the same plane have the same trace on a line L, such that all the traces of either figure are distinct, the figures are said to be perspective from L. The line L is called the axis of perspectivity. Additional definitions of perspective figures will be given in the next chapter, page 56. These are sufficient for our present purpose. Definition: to project a figure in a plane alpha from a point O onto a plane alpha prime distinct from alpha is to form the section by alpha prime of the projection of the given figure from O. To project a set of points of a line L from a point O onto a line L prime distinct from L but in the same plane with L and O is to form the section by L prime of the projection of the set of points from O. Clearly, in either case, the two figures are perspective from O, provided O is not on either of the planes alpha, alpha prime, or the lines L or L prime. Exercise: what is the dual of the process described in the last definition? The notions of projection and section and perspectivity are fundamental in all that follows. They will be made use of almost immediately in deriving one of the most important theorems of projective geometry. We proceed first, however, to define an important class of figures.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.